I will go ahead and introduce the third speaker for our second session, Justin Devoe with Shoma Construction. Justin is known as a passionate builder and supporter of new technologies, recently overseeing construction of the first hybrid steel and cross-laminated timber student residence hall in the Northeast. Justin has extensive experience managing large, complex public and private construction projects throughout the New England education market. We appreciate him taking the time to be with us today and sharing his knowledge. Justin?
Good morning, everybody. Thank you to the WoodWorks Wood Products Council for this opportunity here to present to you all. It's a really kind of topic near and dear to my heart. I'm a big supporter of, wood construction, mass timber, CLT. There's, a lot of value, as you heard from the previous presenters here. A lot of the same themes will continue to come up with regards to the proper planning and how beneficial, to get involved early, get trade partners involved early, design team early can be towards executing a mass timber or CLT project. So with that, I'm going to share my screen. Okay, so here's a quick agenda for what I'll go through today with the presentation. The case study is mainly based on a project at the Rhode Island School of Design called North Hall, which is a new 41,000 square foot, 148 bed residence hall, which was completed in the fall of 2019 for occupancy. And there's going to be also some discussion of a project that's currently under construction at Brown University. The project is called Wellness and Residence Hall. It's a new out of the ground full spectrum health services facility with residence hall also included in the program. Both buildings utilized a CLT hybrid structure, which incorporates cross-laminated timber decking into a traditionally steel-framed building. The second section, I'll focus on, a lot of the things that you've already heard, but with respect to this project in terms of planning and how to optimize logistics and schedule with proper planning. Section 3, I'll get into some execution of the early planning, and then we'll talk about some lessons learned and final thoughts at the end, along with some finished photos of the RISD building. So for some project context, I realize, broad audience here. So for those of you unfamiliar with RISD, it's like I said, Rhode Island School of Design. It's one of the most well-renowned design schools in the world, really. Here's a photo of the project site before the building was built in the existing quad area. The house that you see, the smaller house in the middle, was actually demolished in order to allow for the new building to be constructed. It was RISD's first new residence hall actually since the 1980s. And then the buildings that you can see towards the top of the photo here are existing dormitories. So part of the intent here of the new project was to allow the new building to act as swing space for these subsequent renovations to be able to happen, as they looked at a growing student population living on campus. They really started planning this project in 2016, and the need was going to be in the next 5 years or so. So we're there now. So some of the key challenges that we faced were just the schedule that the job needed to be completed in to allow the subsequent renovations to happen. Once we completed enabling work, which was the demolition of the existing structure on the site, as well as some utility enabling work, we had about 12 months to build the building. I'll get into it a little bit more, but that was one of the main factors that played into our decision to use the CLT based on the speed of installation. The school also, had some pretty aggressive sustainability goals, being a design school, which was another consideration that using CLT contributed to. We were trying to keep parity between the buildings, understanding that it's residence halls that were built in the 1960s were going to be a lot different than one newly built, even if the renovations updated them after the fact. But we, wanted to be cognizant of not creating a premium living environment for students. This is a whole quad area here on this one block is for the first year students at RISD, and they wanted parity between the buildings. One of the design goals was to create an artist loft experience. The building is really set up as a work-live type of space. So something that we considered with all of the decisions we made on the project. And there was definitely a strong interest from both the university and the design team from the get-go, and wood products and mass timber. Ultimately, we ended up with CLT only, but it was definitely something we considered all along. Here's a high overview of the schedule. So there was master planning done, like I mentioned, back in 2016 and 17. We had a very long design period for most projects, but it was actually truncated from the perspective that this was actually the contract setup on this project was IPD. For those who don't know what that is, it's integrated project delivery. So this was a very compressed period to do a full integrated project delivery process. But the team, met early on in 2018, game plan for what we needed to do to start towards the end of the summer of the same year, and move along into construction. And like I said, be open in 12 months for August of 2019. Here's just some photos of our integrated project delivery process in action. So really, one of the key aspects here is that the entire team engages very early on in the process, including designers, the construction manager, along with the owner, and also the key trade contractors. So I think it was Chris who mentioned when you can get trade partners involved early, it really benefits the process. So you get, the experts from your concrete, your rough carpentry, all your MEP trades in the room to really inform the design and help make sure that you have a building that's going to be able to be built very effectively and efficiently. The next slide is a choosing by advantages. This is an actual example of the choosing by advantages process that we worked on to determine the structural system to be used for this building. So choosing by advantages is a process that's key to IPD and lean practices. What it basically does is it's an update to the pros and cons type of weighing a decision to reach an ideal conclusion. The options that we had assessed were a steel and precast girder plank building, which was the basis of design, a full mass timber structure, as well as the CLT hybrid structure. So what this choosing by advantages process does is you basically consider all of the advantages that a system could have based on the criteria set forth by the team as being the most important selection criteria. So you can see over here, if it's not too much of an eye test for you, logistics and constructability, schedule, aesthetics, durability, sustainability, system integration, and fit and finish. So then you basically go through and come up with all the advantages and list out the advantages for each criteria. For all the options, there's really no disadvantages, because a disadvantage for one option creates an advantage for one or more other options. Also, a advantage or a disadvantage that's across the board true for all options doesn't get considered because it doesn't create an advantage for any one particular option. Once you're done creating the advantages, you weigh the criteria with a point system. Based on the importance of that criteria, and you basically come up with a score at the bottom that gives you what your ideal solution would be to your problem. and cost is not considered during this process. Cost is considered after the fact. That way you don't have costs clouding the judgment on coming up with what would be the best solution. Cost is certainly considered at the end to weigh the cost versus what it would take to get to the ideal solution. So we went through the process here, and actually CLT hybrid was the top scoring. It had a small premium associated with it, which I can get into a little bit further in my presentation, which, some of that premium was really mitigated by schedule achievement here, and how much better we did than we thought we could do in terms of the installation sequence of the CLT. So after we had made our decision, some of the pre-construction considerations that we had were in the dorm rooms themselves. The designers were, one of their key design elements was to keep these ceilings really clean, not have any elements installed on them, which there were some challenges with, obviously, with lighting, HVAC, fire protection. The building was fully sprinklered. We had to come up with a plan to be able to bring all those services into the dorm rooms and still maintain a clean ceiling so that we could really highlight and showcase the CLT product. There were a couple of instances where we weren't able to keep things off the ceiling, but they were very minimal. And when we had to come up with a solution, the team really put their heads together to try to find solutions that did not detract from the beauty and the aesthetics of the product. Over here, we have some isometric views of the structure. So this is, again, the steel frame with the CLT slabs. One really beneficial element when we had decided to go with the CLT is the structural engineer knew there would be some savings, but at that point, we were in conceptual design, and in the steel budget was really based on a cost based on pounds of steel per square foot of the building, which is just a typical budgeting process. So once we really got into it, we realized that there was going to be significant savings in the amount of steel required to support the CLT versus the girder plank. So because the CLT planks could be fabricated 50 feet long, they could span the entire width of our building in one piece, and it was a 3-bay design. You can see that there were the ribbon that runs around the entire perimeter of the building, and then 2 steel girders that ran each side of the corridors through the center of the building. A lot of the members that ran east to west in the building were able to be eliminated, which would not have been able to be done with the concrete girder plank. Next, just a couple of actual details from the documents on this particular project. Another implication that we had to deal with was STC requirements between floors for the dorm rooms. So with leaving the ceiling exposed, we had to deal with the STC and acoustical separation with the flooring system. So you can see here we had our 5-ply CLT panels attached to the steel plank using screws, and on top of that an acoustical mat and then a gypcrete topping slab. And one of the major advantages of doing the gypcrete was not only that it got us our acoustical separation between floors, it also allowed the building to be enclosed and weather tight ahead of pouring the topping slab. So anybody familiar with the precast girder plank building, you typically pour a topping slab on top of it before your exterior walls get installed. In this case, we were able to put the CLT on top of the steel and start building our exterior walls immediately to allow the building to get weather tight and not have to protect it temporarily to do topping slabs, which would have been a challenge on this particular project as it was right in the middle of the winter months. This slide shows the original, like I mentioned, 50-foot long panel, 8 feet wide. What we realized pretty quickly is that that was not going to work very well for our column grid layout. So we worked with the architect to optimize the not only the layout of the panels, but also reduce the waste that was created. I think we had gone from, there was actually an interim between these two images here where we had optimized the width of the panels, but there was a lot of waste. And then, like I said, the architect, Nada, had worked to come up with a layout that really, really eliminated waste almost down to nothing, which was a big win. And we also, another strategy we used to try to reduce waste as much as possible. Some of these cutout areas we had actually had the pieces that were cut off delivered to the job site and then brought to our millwork fabrication shop to make some millwork elements for the building. One of the main reasons that we wanted to keep the grid layout the same and make sure that we could notch all the panels around the grid was that we made the columns for the buildings. It was only one break in them and it wasn't a welded splice, it was a bolted splice. So we wanted to be able to erect the columns and then install the CLT around those columns.
Hey, Justin, I'll give you a heads up. I know you still got a lot of slides. You got about 5 minutes left.
Okay, I will put it in 5th gear. Is a photo of the splines where you get the diaphragm. So originally we had plywood spanning the entire product to get us our diaphragm for the building. We were able to change that to just a spline detail here. And one of the ways we were able to do it efficiently is the installer made some templates with the nailing pattern, put them on the spline, spray painted them so that they could go through quickly with the nail gun and hit the nails. Here's a detail of the column as it passes through the slab being notched around. I think it was mentioned previously how important it is to make sure that the structural model makes it into the hands of the CLT fabricator to make sure that the panels come out to fit around everything without having to be modified in the field. Here's a detail on the left of a relieving angle for the brick, and then a photo on the right of it actually being installed. In terms of MEP coordination, because it was an IPD process and we had all the trade partners on board, we were able to get the models done and coordinate penetrations both through the structural steel as well as the CLT made in the shop. I know this isn't CLT related, but just given that early involvement, we were able to make 400 shop beam penetrations, which are about 25% of the cost of a field beam penetration made without having to make any field penetrations. We had less penetrations in the CLT, probably in the range of 50 or so, but those were all, again, anything above 6 inches, round or square, was made in the shop. And anything smaller, we were able to cut easily in the field. It's a photo of some of the MEPs installed in the corridor, as well as the MEPs passing through some of those shop-made penetrations. In terms of field execution, run through this as quick as I can. Here's some photos. Safety rails being able to be installed with the same crew that installed the CLT was a huge win, and we could get on the decks to work immediately after they were installed, as well as all the holes were able to be protected right away, so there was no tripping hazards. It's a photo of some of the shop-made penetrations as well. Here's a map of Providence here. This is laydown area that we used. So we were able to get all the CLT delivered to the laydown area and then bring it over to the site, which was a pretty tight site as we needed it to allow for, you know, like I mentioned before, we had, you know, thought we could save on the schedule. Originally, we had about 2 months for the steel and concrete girder. We anticipated we could save 2 weeks and do it in 6 weeks with the CLT, and we ended up actually installing the entire structure in 2.5 to 3 weeks. So it was great that we had that laydown area, had all the material there because we weren't waiting around based on our initial plan on the schedule. Some photos of the drawings we had used to determine how many pieces of the plank we could get on a truck, and also one of the trailers on the site. Some overhead shots of the plank being installed in the structure above it. And again, you can see these, this is half of the column with a bolted connection that was made later after the CLT was installed around the columns, which was key. Some more drone photos of that process. This is a photo of the screws being installed from the steel into the plank after it was installed. Some of these are videos, but I know we don't have time for that. Here's a photo showing how we were able to eliminate a lot of the cross members of steel and save on the actual steel cost. Some of the bolted connections in the columns. Attachment to the deck at the column locations. Unreinforced openings were also key. We were able to eliminate a lot of, you typically see reinforcement with structure and angles and things like that at openings. We were able to make a lot of smaller, you call them smaller, but significant openings for shafts and things like that without reinforcing them, which was great. Some photos of our topping off ceremony and a completed photo of the structure. Lessons learned, you know, we carried over a lot of these lessons learned from RISD over to the Brown project. So the early coordination with the trades. Here's a detail of one thing we weren't able to get off the ceilings on the roof deck. We had davits for tie-off points, so we found a nice detail. We were able to through bolt and have it be a pretty clean look there with our roof davits. A lot of the same details, like I said, carried over in terms of the column penetrations. Here's our acoustical mat and the nailing pattern. This is a time lapse of the structure, which we probably don't have time for, unfortunately, but I can share with WoodWorks if anybody's interested. And then just some final photos of the completed RISD building, which, like I said, is a work live space. It really came out beautiful. It was a great project, huge success for RISD and the entire IPD team. So it's a project we're very proud of. And those nice clean CLT ceilings we were able to maintain as envisioned. And that's it. So again, thanks for the opportunity and looking forward to some question and answer.